So how do we come up with the graph of a function? Well, if we know something about the function that we're graphing, there are lots of techniques that we can use. But if we just come in knowing that we just have a function, we don't know anything about what its graph is going to look like, our first approach is going to be to create what's called a table of values. And then we'll use that table of values to get some points on the graph. And looking at the points on the graph, we'll then say, well, what does this graph look like? So in this example, you probably know approximately what the graph is going to look like, but let's approach this as if we don't know anything. So f of x is the function 2/3 x minus 5. The first thing we're going to do is go through and figure out the outputs associated with each of a list of inputs. And I chose these inputs for x counting by threes so that at every step we're going to be multiplying this 2/3 by a multiple of 3, and we're always going to get integers for our outputs. So when x is -6, we're going to take f of -6 is 2/3 times -6 minus 5. And now you can absolutely do this on a calculator if you so desire. I'm going to do this arithmetic on a calculator, and I get that this comes out to -9. So input -6 gives us output -9. When x is -3, we'll take f of -3 equals 2/3 times -3 minus 5. And that comes out to -7. So input -3 gives us output -7. What about 0? When x is 0, we'll take f of 0, which is 2/3 times 0 minus 5, which works out to -5. Input 0 gives output -5. When x is 3, we'll take f of 3, which is 2/3 times 3 minus 5, which works out to -3. And finally, when x is 6, we'll take f of 6, which is 2/3 times 6 minus 5, which works out to -1. Input 6 gives output -1. I forgot to copy input 3 gives output -3. So this is a table of values, or an input-output table. And now we can take our table of values, or input-output table, and translate that into a graph. I just put a copy of the table down next to the axes so we can have them on screen at the same time. -6, -9, that's below the bottom of my graph, so I'm not going to draw that. Then I have -3, -7. So that's the -3 on the x-axis, the -7 on the y-axis. This point here is -3, -7. Then I have 0, -5. So x equals 0 along the y-axis. Y is -5 here. So 0, -5. 3, -3. That's right here. And then 6, -1, that's up here. And we notice that these points we drew line up along a straight line. We probably already noticed that this equation was a linear equation. So we were hoping that the points were going to line up along a straight line. And in fact, that's what we see. So in order to actually graph the function, we're going to actually draw in that line. And here's our line. That's the graph of our function. If we like, we can label it with the name of the function, f. And now, you might have noticed that the expression for this function was a linear expression, and the graph of this function happened to be a straight line. This will not happen with every function, but it does happen with many functions, in particular, the ones whose expressions are linear expressions. But it's certainly not the case that every time we graph a function, the graph is going to be a straight line.